Question 5. On a frictionless horizontal airtable, puck A with mass ma equals 0.25 kilograms is moving toward puck B with mass mb equals 0.4 kilograms, which is initially at rest. Okay, so let's draw them. Here is B, which is 0.40 kilograms, and its initial speed is equal to 0. It's stopped. And over here, I'm going to have puck A with 0.25 kilograms moving towards the right with V sub A initial is equal... doesn't seem to give it. Let's put a question mark here. After the collision, so this is before, after. It's the Subway diet. Okay. Afterwards, got the same frictionless table. Puck A has velocity 0.13 meters per second to the left. Okay, so it has started off moving to the right, and now it's moving to the left. So I will say V sub A final is negative 0.13 meters per second. And for puck B, it says has a velocity of 0.65 meters per second to the right. So VB final equals plus 0.65 meters per second. And it asks how much energy is lost from the system during the collision. So it's asking for kinetic energy change. So find delta K. The problem here is that we don't have V sub A. So we need V sub A initial. That was never given. So what we're going to do is note that there's no net external force. It's a frictionless system. There is going to be the force of gravity in these pucks pulling down, but that's going to be cancelled by the normal force from the table acting up. So there's no net vertical force for sure. And as for horizontal forces, the only one would be friction, but it says frictionless. So if there's no net outside forces, the P final equals P initial. That's the conservation of linear momentum. So we're going to say P final is equal to MA times VA final plus MB times VB final is equal to the initial momentum, which was MA VA initial plus 0, because puck B is at rest, right, initially. So we're going to just solve for that one we didn't know. V sub A initial. V sub A initial is equal to 1 over the mass of A times, sorry about my handwriting, MA times VAF. But I guess if you've all been watching me write on the chalkboard all semester, you've gotten used to my messy handwriting. So that's what that looks like. I think probably best thing to do is let's plug this into our calculator now, just so that we have this initial velocity, because we're going to use it for kinetic energy before and after. So 1 over 0.25 is the mass of A times 0.25 times negative 0.13 plus 0.4 is the mass of B times positive 0.65 meters per second. Plugging all that into my calculator, I ended up with VA initial equals 0.91, lots of zeros after that, meters per second. And it was positive, so, which is kind of a good sanity check, right? So this is to the right, just as the problem specified. If it had been negative, I would have been a little bit worried. But, so this is okay. So now, we can find kinetic energy. So find kinetic before and after. So kinetic initial is going to be 1/2 ma times va initial squared plus 0, right, because the other one's at rest. So this just equals, let's figure it out numerically again so we can compare, 0.25 times that initial we just solved for, 0.91 squared. Plugging that into my calculator, I got 0.1035, etc. joules. Okay, and then the final kinetic energy is going to be 1/2 ma times va final squared plus 1/2 mb vb final squared. Let's put the numbers in. 1/2 times 0.25 times negative 0.13 squared, but when you square a negative that will become positive, so it'll be a positive contribution to the kinetic energy, plus 1/2 0.4 times 0.65 squared. Plugging that into my calculator, I got 0.08661 joules. Okay, so which is less, so that's good. So energy is lost, which the wording of the equation, the wording of the question sort of indicated that it might be a little bit inelastic. So energy is lost. That happens a lot in collisions. So your delta K is the difference of these two. So plugging that into my calculator, 0.08661 minus 0.1035 joules is equal to negative 0.0169 joules. So the loss, the amount of loss, is 0.017 joules. So looking up to see if that's one of our choices. Yep, it is. So the answer is B.